So everybody's good with that, right? So, this is what you all will be seeing here in about 10 minutes. Well, we'll do this one together. Just hang. These are all on your slides and Google Classroom. You all do need to do the Punnett square with them. So you all are going to need to create the Punnett square that I'm creating. If you want to write it, you can. But you all do need to do this Punnett square as I'm doing. Okay? So, calculate the probability for an offspring from two parent cats. One is going to be homozygous dominant for a long tail. What will its genotype look like?
No, big T, big T.
Big T, big T. Why?
Because
It's dominant and
homozygous.
homozygous.
Yeah.
Okay? So, we're going to draw a box. Cut it into 4 equal sections. Homozygous dominant, we're going to put those up here at the top.
Does it matter where they go?
No, it does not matter which parent goes on which side. Everybody good so far?
Yeah.
Okay. Second parent is homozygous recessive for a short tail. So what will its genotype be? Little t, little t. That's going to go on this left side of the box. Everybody good so far?
Little D or just plus sign?
Yes. So this big T, he gets to slide down. These are his 2 boxes, right?
Yeah.
So he gets to come down through here, putting a big T in this box, big T in that box. This T is going to do the same thing. So all of your boxes should have 1 capital T for this problem, right? Everybody good so far?
You're
Anybody lost and confused? Okay. This T, remember, it owns these 2 boxes. So it gets to come across here and here. Same thing with this bottom T. It gets to slide across for this box and this box. Big T is what phenotype? Long tail. Little t is what phenotype? So, if I say a cat is going to be homozygous dominant for a long tail, what genotype will it have?
Long tail. T, one, big T.
Genotype. Genotype is the what?
Big T, little T, big T.
Genotype is what? Letters. So if it is homozygous dominant, what will its genotype be?
Big T, big T.
Big T, big T. If it is homozygous recessive, 2 little t's. Then it's heterozygous, big T, little t. What are the chances for the offspring to be born homozygous dominant for a long tail? 0%. Why? None of the boxes have that genotype, right? Little t, what's the percentage? 0%. What about big T, little t? 100%. So, if all the offspring are going to express the big T, little t phenotype or genotype, what phenotype will all of the offspring have? Long tail. Does that make sense?
How would it be spread on though? It's like there's 2 big T's and now there's 2 little T's, whatever happened. Like, what are the offspring? How would this like the offspring?
You mean like these offspring?
Yeah, like whatever.
So, like if I would do a Punnett square for these offspring, they have 1 T, 1 allele is big T, 1 allele is little t. So then you go about the same.
Yeah.
So, you all are going to explain number 2 to me. I don't know how to do this. We are going to cross 2 parent horses and determine the probability that that offspring will have a black coat. What do I need to do first?
Create a square.
Make a square, okay? Now what?
Right here.
Draw lines?
One vertical, one
No, separate it into 4 equal parts.
Separate it into 4 equal parts, right? I'm gonna do exactly what you all tell me to do. So, we're in 4 equal parts. Now what?
Put 2 little bees on the top. And 2 big bees on the left.
No.
Over each
What?
box.
one over each box.
So, one allele's gonna go where?
Over each box.
One allele over each box. For which parent? Does it matter?
No.
No.
Yes.
What do you mean?
Okay,
Parent 1.
Parent
So what am
one.
I gonna put here?
parent one will be 2 alleles on top.
What's gonna be here?
A little b.
This is gonna be who?
Parent one.
That's just a little P markers.
Now what?
2 big bees
On the left
over
side.
each column
No,
on each
what's that
side.
being?
The side.
One big B where?
Over yonder.
Over
To the left. To the left side.
Over yonder.
To the left side of what?
The top.
Box.
Top
The
left.
left side of the top,
Give
the
me
left side of the
something
top left
for you.
square.
Left side of the top left square. Okay, there we go. Now what?
A little bit. On below it. On the left side of the bottom left.
Okay. Who's that gonna be?
Perfect.
Now what?
Now, you're gonna bring your little b down in its column. Like,
Which
down
little
its
b?
whole
Put,
column.
put 1 little bee in each column.
Yes.
Put one little b in
Yes.
every square.
Why?
Because you have to bring it down to see your
Yeah.
Back?
Yeah.
You gotta get
Yeah.
Good job.
Now what?
Do the same thing for the parent too, but then like
Do the same thing for parent two with both of its letters. Bring
Put
up
a
the
big bee
column.
in the 2 top boxes.
Okay.
Person talking.
So I drag this across like this?
Yes.
Now what?
Now
then
put
you
another
bottom,
little
the
bee.
bottom across.
So there's a 50% chance it could be,
Yeah.
dominant 50%.
So, which trait is gonna be my dominant trait? What coat color does that represent?
Black.
Big B is black. What is little b?
Chestnut.
What possible genotypes could I have? What?
Homozygous, recessive, and hetero.
Homozygous dominant?
No.
No.
Homozygous recessive.
Homozygous recessive? What's my other possible genotype? Heterozygous. What percentage of my offspring will have a homozygous dominant genotype?
0.
0.
So, yeah. So
What percentage will be homozygous recessive?
There's only 50% left, so 50.
and then it would be 50.
What percentage of my offspring will be heterozygous?
50%.
I got it.
If its genotype is big B, what is the phenotype gonna be?
black.
Black. If the genotype is little b, chestnut, why? 2 alleles, and how many copies of the recessive allele do you need to see the recessive phenotype? 2. Big B, little b, what's my genotype, or phenotype gonna be?
Black.
Black, white.
It's
1 copy of the dominant allele, right? Okay, you all are gonna do this one on your own.
Oh.
Cross 2 pea plants to determine the percent chance the offspring will have white flowers. Parent 1 is big P, little p. Parent 2 has a genotype of big P, little p. Capital P represents purple. Lowercase p represents white.